Alright, so this is A21. Number 5, can f be a fourth degree polynomial? So all we have to do is look at the end behavior of the polynomial and notice that the left is going down and the right is going up, so that this indicates that this is an odd degree polynomial. So the answer for this is no. For it to be a fourth degree, both ends have to go up or both of them have to go down. Number 6, can the leading coefficient of the graph of f be negative? Well, since the left is going down, right, and the right side is going up, this tells you that the leading coefficient, or a, is positive, not negative. Okay, so the answer for this one again is no. Alright, so for 9 through 16, we're going to match the graphs with the functions, with the equations. So I'll start like for number 9, notice how it's a linear function. And so the only line that we see here is here. And of course the slope is negative, but again it's the only line, right? So we know that this one is f. And then I noticed that we have two parabolas, this one here and this one here. And we have number 11, number 10 are both parabolas, are both quadratic, so I know that those have to be, matched up with C and H. So number 11 has a negative A value and number 10 has a positive. So I know that 10 opens up, so that's going to be H. I know that 11 opens down, so that's going to be C. Okay, next up I notice that I have two equations, 13 and 15, with even degree, and 14, 16 with odd degrees. So I'm going to do the 13, 15 first, since I know that for even degrees, both the left and right go in the same direction. So I notice that letter E, notice how the left goes down and the right goes down. And then for letter G, the left goes up and the right goes up. So these two, E and G, are your even powered polynomials, even degree. So 13 and 15 are going to be paired up with these two. Now, how do you know which to pair up with which without using a graphing calculator? Well, you look at the A value. So 13 is negative, 15 is positive. So 13 is going to have a down-down end behavior, so that's going to be letter E. And 15 is going to be an up-up, so that's going to be letter G. Okay, 3 to go. So I've got 12 and 14 that both are cubic, and 16 that's to the 5th power. So I know that, I know that it has two turns, one here and one here, and then this one also has two turning points, right here and then right here. And this one has, 1, 2, 3, 4 turning points. So B cannot possibly be matched up with 12 or 14 because 12 and 14, the maximum number of turning points it could have is 2, because 3 minus 1 is 2. Okay, so I know that B has to be number 16. So B has to be number 16. And for 12 and 14, I've got A and I've got D to choose from, right? So again, how do I pair them up? Well, I notice that 12 has a positive A and 14 has a negative A. Okay? So positive A means that it's down up, so that the left side is down and the right side is up. Well, if you look at A, the left side is down, the right side is up. So then that means that this is A, and 14 is the opposite, right, because A is negative. So notice how on D, the left side is up and the right side is down. Okay, so that one would be D. Alright, so for numbers 38 on, they're asking you to find the zeros algebraically. Find the zeros algebraically, and in order to do that, for the most part, we're going to be factoring. So let's take a look at number 38. So I've got 5x squared minus 10x minus 5. So the first thing I do is see if there's a common factor, a greatest common factor other than 1. So in this case, yes, we have a 5. Okay, so you get 2x minus 1. You check to see if your quadratic is factorable, and this one unfortunately is not. No factors of -1 add up to -2. No pairs of factors. So then we have to use quadratic formula. So b is -2, so the opposite of -2 is +2. Then we have b squared, which is -2 squared, minus 4 times a times c, all over 2 times 1, 2 times a. And simply, that's a negative right there. So then we do 2 plus or minus the square root of 4 plus 4 over 2. And so this gives us 2 plus or minus square root of 8 over 2. So we can simplify square root of 8 to 2 radical 2, because 8 is 4 times 2, so the 4 could come out, the square root of 4 comes out, and this 2 stays inside the radical. Okay, all over 2. And remember, I think I mentioned in class, do not cross out the 2 and the 2 right here. They do not cancel. What you guys need to do is factor out a 2 from the numerator, and then now you can reduce 2 over 2 as 1. So the zeros for number 38 are 1 plus or minus square root of 2. So those are the 2 zeros. Now it says that you can use that for parts B and C to use a graphing calculator. So by all means, use Desmos.com, or if you have your own graphing calculator, go ahead and use it to approximate the zeros. Okay, and see how, use a calculator to get the approximate value, and what you see on the graph should be this value, these two values right here. This is where the graph crosses the x-axis. Alright, for 42, again, first thing you look for, see if there's a greatest common denominator other than 1, and so in this case we have a t in common with every term. So I'm going to factor out the t, so that leaves me with t to the 4th minus 6t squared plus 9. Okay, so even though this is not a quadratic function inside the parentheses, I can treat it that way when I factor, because 4 is twice as big as 2. So then I can factor it like I would a quadratic. Okay, so I keep the t out. So this would be t squared, and factors of 9 that add up to -6 would be -3 and -3, so notice how it's the same. So I can write it twice, or I can just put t squared minus 3 squared. Okay, and we set each one equal to 0, so the zeros are 0 for this one right here, and for this factor right here, it's plus or minus square root of 3. Okay, remember how I showed you in class? You set the factor, you could do one of two things. You could set the factor equal to 0, so t squared minus 3 equals 0. Move the 3 over, so that leaves you with t squared equals 3. Take the square root, and that's where you get plus or minus radical 3. Or you can factor it and just write the two factors, t plus radical 3 and t minus radical 3, and then solve each one, set each one equal to 0, and you'll get the same answer. Alright, so 46, I did not mean to assign that one because the process for finding the zeros of this one, even though you covered it last year in Integrated 3, it was, we didn't review it in class because actually it comes in the next section, so I don't know why. I guess because they're assuming that you that you're using a graphing calculator and you could find the zeros that way. but as far as finding them algebraically, I'd rather save it for when we get to the next section. Okay, because I want to just focus in, again, since I didn't review it in class, I don't know how, this problem should be saved for section 2, 3, because I'd rather